Okay, so can everybody see that okay? Awesome. So welcome everybody to the final day of the KINect Research Week for 2021. We've had some really great talks on Monday from Andrew Friesen and also from Dr. Guylaine Desmarais in Laval on Wednesday. So today we're not featuring external individuals. We're going to focus on our own department. And in some ways, this is sort of at least my favorite part of KINect Research Week, because we get to gain a little bit of perspective on what our colleagues are doing, and then people in the University of Winnipeg community can see what's happening inside our department. And obviously, sort of the COVID-19 pandemic sort of exacerbated the distance between all of us. So this is a really great opportunity to connect in a research capacity. And it'll give us a really cool perspective of what's to come once we're fully back on campus and that research activities kind of ramp up back to normal. So here I've listed the kind of flow of events here. I'll start off by giving a talk, and then there'll be 4 other talks. The goal will be to kind of have about a 10 to 15 minute presentation followed by a brief question period between each of the presentations. So my talk today is going to be titled Predictors of Expiratory Flow Limitation During Exercise in Healthy Males, Females and Males. So this is a project that has been sort of complicated by the COVID-19 pandemic, but it's been in the works for a couple of years, and I'm excited to sort of share our findings so far. So the first thing I want to present is, as I was reflecting on Dr. Desmarais' presentation on Wednesday, who highlighted the large gap between males and females in terms of coaches. I realized that that's also true for the world of biomedical sciences, whereby the influence of sex and gender are rarely considered in biomedical investigations. So this is a little comic here that was written or made by Etta Hume in 1991, and it kind of summarizes that quite nicely, I find. Now, Etta Hume in the 1980s was sort of in the twilight of her career, and was one of about 5 or 6 editorial columnists that were hired full-time to work on cartoons like this that were female. So obviously, female in a male-dominated field was pretty problematic. Unfortunately, Etta Hume died in 2014, and ironically enough, it's the same year that Virginia Miller from the Mayo Clinic in Minnesota published an article, and I've taken an excerpt from that article because it essentially deals with the topic of assessing the influences of sex and gender in human biology studies. And so I'll read the quote verbatim here, and it says that although sex is a fundamental aspect of human physiology that splits the population into 2 approximately equal halves, this essential biological variable is rarely considered in the design of basic physiological studies, in translating the findings from basic science to clinical research, or in developing personalized medical strategies. Now, of course, this is a huge problem that we need to address, and some of my work focuses on addressing that gap. So before I talk about my study, I want to define a few key terms, and the first term is expiratory flow limitation. Whether or not you realize that you've probably experienced this to some extent, or many of you may have, particularly in the context of exercise. So it's something that occurs when expiratory airflow, so airflow when you're breathing out, can't be further increased even if you try harder, even if you try to breathe out harder. It is very common in patients with chronic respiratory disease. So as an example, asthma and chronic obstructive pulmonary disease, or COPD. However, it also occurs in healthy individuals at a rate of approximately 50%. And it's usually, it only occurs during really high intensity exercise. So we can look at expiratory flow limitation using spirometry, and it'll give you some idea, at least empirically, of what it looks like. So here, I'm just going to pull up a pointer here that might be helpful. So you've got airflow on the y-axis in liters per second. And on the horizontal axis, we have volume in liters. And if you imagine that you take a really big breath in until your lungs are completely full, going from residual volume to total lung capacity, and then blast the air out as hard and as fast as you can until your lungs are completely empty, this would be the sort of profile that we would see in a standard kind of healthy human. And this black line sort of shows you the limits of where you can breathe. You can only breathe inside this loop. You can't breathe out of it. It's a physical impossibility. So while we're all sitting here at rest, the green circle that's being formed here represents a breath in and a breath out. As we exercise, of course, we breathe more air and we breathe faster. So you end up with a larger loop, and we're utilizing a greater fraction of our available ventilatory capacity, or available ability to move air. Now, during high intensity exercise, obviously, we're using even more of this capacity. And in some cases, certain individuals can use so much of that capacity that they actually experience expiratory flow limitation. So it implies that this red line here is intersecting with that thick black line. So why would EFL or expiratory flow limitation be important? Well, it's associated with several negative physiological consequences. For example, it forces people to breathe at high lung volumes, which is quite uncomfortable. It increases the amount of work the respiratory muscles need to do in order to breathe. It can lead to exercise-induced arterial hypoxemia, which is a fancy way of saying that you get a reduction in the amount of oxygen that's in your blood. It can lead to dyspnea or breathlessness, as well as impair exercise performance. So I'm just going to highlight the last one because this is a lot of information. This series of figures comes from a study where expiratory flow limitation was imposed while healthy individuals were exercising. And so if you look here on the x-axis, you have the percentage of exercise intensity, I suppose. And then on the y-axis, you have a unitless measure of someone's perception of breathlessness. And during the control run, where they had no flow limitation, breathlessness was relatively moderate, but when it was imposed experimentally, it increased the perception of breathlessness quite substantially. And unsurprisingly, this led to a 44% reduction in the capacity to exercise. So that's obviously an extreme example of what flow limitation can do if it's present in an individual. It will cause dyspnea and impair exercise performance. So what are the causes of EFL? I want to emphasize that they're complex and multifactorial. But they involve a combination of factors that relate to three main components that will come up a few times in my presentation. So one would be physical characteristics. If you take someone's age, for example, pulmonary function unfortunately declines with advancing age, regardless of health status. And so older adults are more predisposed to EFL than younger adults. Pulmonary function obviously is a really important thing. So I showed you the spirometry measures. This will determine how much we can breathe. So if somebody has low pulmonary function versus high pulmonary function, it will obviously affect their ability to, or their risk of developing EFL. And then also how we breathe. So certain individuals breathe lots when they exercise because they may be fitter, and others breathe less. So that'll also influence the risk of developing flow limitation. So these color codes here that I've highlighted, so blue, red, and green, they're going to come up in the presentation later to represent these three categories of factors. So if we focus again on the notion of evaluating the influence of sex, it's been suggested that flow limitation may occur more frequently in females than in males. And this is a relatively recent idea. So this is based on the notion that certain morphological differences exist in the human respiratory system. So specifically, the rib cage, lungs, and airways differ in terms of size and shape, which has functional consequences during exercise. So this led investigators to assess the prevalence of flow limitation and compare it between males and females in health. And it was suggested, based on two very small studies, that females are more likely to experience flow limitation than males. Not great to do small studies to determine prevalences, so that's a fairly limited idea, but it's something that's worth investigating. It's also possible that the mechanisms of flow limitation differ. So it's been suggested that males might develop flow limitation due to differences in breathing pattern, whereas females may be more predisposed to flow limitation due to differences in pulmonary function. So it's worth investigating these things so that we can understand the similarities and differences between males and females. So that brings me to the aims and hypotheses of this study. We sought to kind of evaluate the prevalence of flow limitation in males and females, particularly during exercise, and determine what factors predict EFL and whether they differ based on sex. Our hypotheses were twofold. We first hypothesized that the prevalence would actually be similar. So I can't think of a compelling reason why there would be differences between males and females here. However, it's possible that the mechanisms differ. So our hypothesis was that males would experience flow limitation due primarily to differences in breathing pattern, so how much you're utilizing your lungs. And in females, those who experience flow limitation, it would be more related to their level of pulmonary function. So if they have slightly smaller lungs or slightly larger lungs, that would affect their likelihood of developing EFL. So this is a study that took quite a while, but basically we wanted to have a large enough sample to really be able to get at the issue of prevalence. So we recruited about 66 females and 60 males. They were between the ages of 20 and 45, never had smoked. Their body mass indices and their pulmonary function were within the normal range, and I can explain that if anybody's curious. Data collection involved three aspects. So we measured their kind of physical characteristics, and we had them fill out information about their age and things like that. We did their pulmonary function testing using spirometry according to society guidelines. And we did a cardiopulmonary exercise test. So they would essentially get on a cycle ergometer. They would be hooked up to a cardiometabolic testing system, and they would exercise at incrementally increasing intensities until they reached their maximum. And of course, we assessed whether or not they were flow limited at each stage of exercise. So I won't go through this in too much detail, but if you have questions about it later, please let me know. This just summarizes the patient characteristics or the individual characteristics. We noticed sex differences in terms of physical characteristics. So on average, males tend to be taller and heavier than females. So this is to be expected. And we also noticed differences in absolute but not relative measures of pulmonary function. So this implies that our subjects were healthy and they were well within the normal range. And we saw the typical kind of sex differences that one would typically observe with when measuring pulmonary function. We also monitored sort of ventilatory and cardiovascular responses throughout exercise. And I'm highlighting the measures at peak exercise here. You'll notice again, as the last slide, those color codes, they represent those three characteristics that I mentioned earlier. So it'll come back later. So here we noticed absolute but not relative differences in terms of basic responses to exercise, particularly at physiological maxima. And we took all of this information and tried to use these variables to predict who would and would not be flow limited and compare that to our actual measures. So looking at the prevalence, this is a fairly simple series of pie charts. Overall, we had 126 participants, and the breakdown of who is flow limited and who is not is about 51 and 49%. So flow limited is in gray, not flow limited is in black. And you can appreciate that this matches quite well with the literature. So 50% is kind of the number that people throw around. So this agrees very nicely with that. And then we noticed that the prevalence did not really differ based on sex. So approximately 55% of 55% of females were flow limited, whereas 47% of males were. And if you run the stats on that, it's not a significant difference in terms of prevalence. So first hypothesis confirmed. The last thing that I'll show before I finish up is the predictors. So what factors in those three categories, physical characteristics, pulmonary function, breathing pattern, actually predicted who became flow limited during exercise and who didn't? Well, we used multiple logistic regression models to do so. And we found that regardless of sex, the likelihood of developing flow limitation is best predicted by factors related to pulmonary function and factors related to how we breathe during exercise. And so this is the detail for the various models. So the first model here is for all individuals. The second model is for just males. And the third model is for just females. And there's a considerable amount of overlap in the factors that predict flow limitation between the two sexes. So really, your ability to generate expired airflow and how you breathe during exercise matter in terms of who becomes flow limited and who doesn't. And it doesn't really differ based on sex, is the take home here. So in terms of conclusions and significance, the first question that we want to answer is, well, what do we know based on this? Well, we know that the prevalence and mechanisms of EFL are similar in males and females during exercise. So this sort of confirms our initial hypothesis, our first one, and it sort of refutes our second one. And it highlights that at least in this specific context, males and females are more similar than they are different. Why does this matter? Well, past studies that have looked at flow limitation have almost exclusively used male participants, which is a problem that we need to rectify. So our study helps address that issue. And it's essential to highlight overall that there are some differences and some similarities in terms of the respiratory physiology of humans, and defining what those are and to what extent they exist is really critical as we move forward. So this is just a bit of a piece of kind of general information related to this that kind of tells us that we're moving in the right direction. Is if you look at CIHR funded studies between 2010 and 2016, there's been a substantial improvement of the consideration of sex and gender in these investigations. So I can sort of predict in the future that our understanding of the influence of sex and gender on various aspects of respiratory physiology will hopefully improve. So that's a good thing. So to finish up, I'd like to thank you all for sort of attending my presentation. And I'd like to thank my collaborators. They're all listed here, but I'd specifically like to highlight the work of Gracie Grift, who's a pretty bright undergraduate student at the University of Winnipeg. And she participated in the Pathway to Graduate Studies program this summer and worked on this project. So I can't take really any of the credit. She did all the analysis. So there's a photo of her. If you see her on campus, you can congratulate her and ask her questions because she'll probably know a little bit more than I do. So with that, I'll stop sharing my screen and open the floor for questions. I think we've got a couple minutes, so feel free to fire away. And you can put the questions in the chat if you're more comfortable with that, or you can just unmute your mic and speak.
You mind if I ask a quick question, Yannick?
Please do, fire away.
Yeah, great. Well, awesome presentation, very interesting results. As someone whose only exposure to expiratory flow limitation was in the last 15 minutes, hopefully the question makes sense. It sounds like it's maybe a new area, but I'm wondering if you could speculate on whether expiratory flow limitation is something that's trainable or adaptable, since people with different chronic diseases and so on experience it. Is it something that for folks that do have it, we can modify it, or does it remain relatively static?
Unfortunately, it is pretty static. You can probably take like a bronchodilator, that you would inhale, kind of like you would in the case of an asthma attack. Probably not warranted for a healthy person, but if you're somebody who experiences breathlessness and that might be related to flow limitation during exercise, there's a lot of pharmaceutical kind of interventions that might help alleviate that. But I have to emphasize that you probably need some medical diagnostic testing to confirm whether that's needed or not. So in healthy people, I definitely don't want to have people worry that they're experiencing flow limitation and they need to get drugs to resolve it. We tend to be quite good at breathing. I don't know if I've convinced you of that, but we're pretty good at breathing. We breathe according to kind of the law of least resistance. So sometimes flow limitation can be tolerable just because the alternatives would be kind of avoiding flow limitation by, say, breathing less, which would be bad, or increasing your lung volume to avoid it. And that comes with its own series of consequences. So the short answer to your question is it depends. But if it is something that's problematic, medical evaluation would often result in people getting a sort of prescription for a bronchodilator, for example.
Oh, great, thanks so much.
There's a question in the chat, Yannick.
Yeah, so has there been any work on sex and gender differences in responsive treatments such as bronchodilators? Really good question. So thanks so much for that. I'm not too familiar with specifically looking at sex differences in terms of the treatment, but I can imagine that there may be some differences. I know that hormonal differences will affect the airway tone, for example. So I would imagine that the response to a bronchodilator might differ based on hormonal status, but I'm not too familiar. It's a question that's certainly worth looking into. Absolutely. Thanks, Neil. Any other questions? All right. Well, I think I'll leave it at that for now. If you've got any other questions, I'd be happy to entertain them later. But I will let our next speaker take over. So our next speaker is Dr. Natalie Richer, who's going to present on the effect of attentional focus on balance and the aging brain.
Thank you, Yannick. Hi, everyone. Thanks for attending today. So I'm doing something a bit different. I started working here last year, mid-pandemic, so I haven't been able to collect data in a while, actually. So instead of showing something that I've done, I'll be sharing the project that I plan to do over the next few years, which is the effect of attentional focus on balance and the aging brain. So what happens when we age? We become less mobile, generally. We suffer some physiological changes, which leads to a loss of balance. So we are less stable, more prone to falls. And these falls are a big problem. About 30% of older adults over the age of 65 will fall each year, and the proportion increases with age. And these falls can be pretty disastrous. They can lead to injuries, loss of independence, and they're one of the leading causes of death in this population. So I'm trying to find ways to improve balance in older adults so that we can prevent or at least delay the falls in this population. And I think that I may have found a way to do so. So I study postural control. Originally, this was something that was viewed as automatic or reflex controlled. We don't really need to think about standing, right? We just do. But there are some attentional requirements that will depend on the task that we're doing, on the age of the person, on the balance abilities. What I propose is that postural control can be automatic and it can be conscious. And we actually tend to shift between the two depending on the task that we're doing. Now, one way that we are able to manipulate automaticity is by using focus of attention. So in an internal focus of attention, we are concentrating on the production of movement. So this could be focusing on the movement of our arms in a golf swing or the position of our wrists. Or if we're standing on a balance platform like the one on the right, which we're trying to keep straight and horizontal, well, it could be to concentrate on keeping the feet horizontal. An external focus, we're concentrating on the effect our movement has on something that's external to us. So in the golf swing, it could be to concentrate on the movement of the club or the trajectory of the ball. Or on this balance platform, it could be to concentrate on keeping that platform horizontal instead of our feet. This is a very small difference in what we're actually just concentrating on, but it makes a big difference in motor performance. So the external focus leads to better motor performance and better motor learning compared to an internal focus of attention. Why? And this is something that I've shown for postural sway as well. So I had with this very nice setup here, very sophisticated little markers extending from the ankles of our participants. We had them focus externally on minimizing movements of these little markers, or internally on minimizing movements of their ankles. And we found that the external focus led to them being more stable. And this was young adults and older adults as well. So why is the external focus better? There is a hypothesis, the constrained action hypothesis, which explains that by removing attention from the production of movement, the external focus allows automatic processes to control the movement, which leads to a more efficient control. On the other hand, the internal focus, you're focusing on movement production, and this is disrupting the automatic processes. But I've tried to prove this, and it's very difficult to prove. The only real way I could think of was to look at what's actually going on in the brain. What brain areas are involved in these different types of focus? Can we actually show automaticity in the external focus condition? And for a while, I didn't think this was possible. Most of the brain imaging methods we use involve laying down in these big devices that measure our brain while we're not moving. But there's been a lot of advances recently with electroencephalography, EEG. EEG records the electrical activity of our brain, and it is very sensitive to motion. So if you wear it and you move, the electrodes move on your scalp, and this creates noise, and we have a hard time reading the signals, but there's actually been a lot of advances. Better systems are being developed, better system configurations as well, and better ways of processing the data, which now allow us to use EEG to look at brain activity during motion. So what I did during my postdoc research was apply this to walking. So we had people walking on this treadmill, uneven surface treadmill. And as you can see, this person is wearing an EEG system on their head and all the amps are attached to the back there. So this is a fully mobile setup and we're able to see what's going on in the brain. So this is really exciting. And I want to apply this to my attentional focus studies to see if I'm able to observe that difference between focus conditions to confirm or deny the constrained action hypothesis. So I'm going to use EEG with young and older adults while they stand quietly, like I've done before, using an internal focus and an external focus to see if I can observe differences in which brain areas are active. I also want to get them moving. Most falls don't happen when we're just standing still. They happen when we're in movement. And think of winters in Canada, those icy sidewalks. How many of us have had a fall? I know I have. So when you face a disruption in walking, sometimes we're able to recover our balance, sometimes we're not. A fall, it can be much more severe in an older adult. So I want to see not only if there is a difference in attentional focus, but can attentional focus help with recovering balance after a perturbation to walking. So these are my two main objectives over the next few years. And I hypothesize, well, first of all, according to the constrained action hypothesis, the external focus would increase automaticity of sway. So I believe this would be represented by more subcortical control. So the lower structures of the brain, like the cerebellum, the brainstem, and the spinal cord as well. These are parts of the nervous system that we can't yet measure with EEG. It can't see that deep in the nervous system. So instead, I think what we'll actually see is a change in the internal focus condition. The internal focus is thought to yield a more conscious control. So I think the cerebral cortex will be more involved. So this could mean an increase in activity in sensory motor areas, the supplementary motor cortex, that's near the top of the brain, so that top arrow there, which is approximate, and the dorsolateral prefrontal cortex in the front. These are areas I believe will see an increase in activity in the internal focus. And we won't see activity in these areas in the external focus as much. I also expect that we'll see differences in young and older adults in how the brain is recruited. But I do hope to observe that the external focus will lead to better balance, better postural control while standing, but also better ability to recover from a balance perturbation or disruption as they are walking. Yeah, so that's what I propose to do. And hopefully, if we do see that the external focus is helping balance, I hope to, my next step would be to use that to create an intervention, a training, to see if we can actually have long-term improvements in people's balance. So I'll open it up to questions.
Awesome. Thanks so much for that presentation, Natalie. So feel free to unmute your mic and ask a question, or you can place them in the chat alternatively. So yeah. anybody doesn't have a question, I might just slide in here. So I might be getting a little bit ahead of myself, but while we were sitting here and I'm not doing any physical activity, my watch told me to breathe. And I'm realizing that these wearable sensors that many of us have on our wrists are getting pretty good at ensuring that we're doing the right thing day to day. And I've heard some grumblings about things like Apple Watches being able to detect falls. Do you have any idea of where your field might go beyond these mechanistic studies? Do you think you could somehow leverage wearable sensors to kind of improve focus such that falls can be avoided?
Possibly. I know even EEG is getting developed. They now have in-ear EEG that can be, I think, pretty accurate, but it's still being studied at the moment. But definitely I hope that so many tools are becoming portable and easy to use, and you could basically get a subject in, set them up with the equipment, send them home, and then have an actual real life experiment where you get real data. I hope that we can get there in the next few years, because it would be much more relevant to study them outside than always in the lab.
Very true. Thanks for that. Any other questions for now?
Well, you guys know where to find me if ever a question comes up.
Totally. And if you've got any questions that come up later, feel free to post them in the chat. We'll kind of keep the discussion fairly open. So with that, I will let Rob take over. So Dr. Robert Price is going to present on patient handling injuries in an urban EMS service, influence of power stretchers, demographics, and seasonal factors.
Oh, great. Well, thanks for the introduction, Yannick, and thanks everybody for having me out. I'm going to assume my mic's working and we can all see this. Perfect. So I'm sure it comes as no surprise to many of us that EMS healthcare practitioners are at a very high risk for workplace injuries. And this is likely because of the exceedingly challenging work environment that they all practice in. However, amongst all of these causes, the most common injuries that EMS practitioners experience are injuries to muscles, bones, and joints. And the majority of these injuries happen when providers are lifting patients or other objects. So one way to help prevent these patient handling injuries is to use something called power assist stretchers. These stretchers use a motor to raise and lower the stretcher. And as a matter of fact, about 5 years ago, every ambulance in Winnipeg was equipped with one of these stretchers. And as we might expect, using a power assist stretcher makes it a lot easier to lift up patients. And more importantly, these benefits, more important.
No, it's just the handle's weird. So.
Sorry, more importantly, these benefits appear to play out in the field where we see dramatic reductions in injury rates reported in a small number of studies. However, like a number of areas of ergonomics, there's still a few gaps that we need to fill. For instance, the only 2 studies in this area both had pretty short follow-up periods, just a year long, and were performed in relatively mild climates. The studies also used fairly simple pre and post tests of injury rates, which didn't allow us to account for things like existing trends in injuries or other factors that might influence injuries. So the objective of this study was to compare injury rates before and after a power stretcher intervention, similar to the other studies, and then to try and extend this work a little bit and examine potential predictors of patient handling injuries or any underlying temporal changes. So to do this, we used about 11 years of data from the Winnipeg Fire Paramedic Service. This included about 4 years before power assist stretchers were rolled out, and then a 5-year period after all of the ambulances had these. Unsurprisingly, our primary outcome of interest were injuries, and specifically injuries that were a little bit more severe. So those ones that required people to take time off from work or seek medical care, as well as injuries that might be specific to patient handling. And then just one thing to clarify on the following slides, when I use the term EMS, I'm actually referring to paramedics that work on the ambulances within the Winnipeg service. And when we refer to fire, I'm referring to paramedics and other providers that work on the fire side of the service, but also respond to medical calls, which is something that's unique to the Winnipeg service. And then lastly, to answer these questions, we did some of the same simple pre and post tests of injury rates, and then followed this up with a few different kind of regression models to try and identify predictors as well as temporal changes. And those models gave us three really important parameters. The first is an estimate of the overall trend, which gives us information about whether injury rates are going up or down over the entire study period. The second is something called the level change, which tells us whether injuries increased or decreased after power assist stretchers rolled out. And then finally, a third that told us whether or not the trend changed. So to start with, just a quick glimpse of the raw data. Across the top, we see all injuries within the Winnipeg Fire Paramedic Service per month for the entire study period. In the middle are the number of monthly medical calls that the service responds to, and then across the bottom, the number of employees or FTEs across the study period. And we can certainly appreciate that it looks like all of these series are increasing over time, but that maybe the increases aren't quite the same across these three factors. So our first real analysis was to do those simple pre and post tests of injury rates. And so we start by looking at injury rates as a function of call volume. And here we found that injuries decreased only for patient handling injuries amongst the ambulance paramedics, but that we saw decreases across the board for practitioners working on the fire side of the service. However, things were a lot more interesting when we examined injuries on a per employee basis, and this is probably the more important outcome measure in this area. And we saw two, I think, surprising things. The first is that the rate of injuries amongst the ambulance paramedics actually went up after power assist stretchers were implemented. And then second, that the injury rates were much higher amongst practitioners that were working on the ambulance side compared to the fire side. So at this point, using the same analysis that previous studies had used, we certainly didn't see those same 40 or 70% reductions in injury rates, which initially I think was a little bit troubling or concerning to us. However, our time series analysis provided a little bit more insight. So this is a graph here of patient handling injury rates amongst those ambulance paramedics across the study time period. And the first thing we did was we fit a line to the pre-intervention period, which combined with that significant trend variable that you can likely see tells us that indeed injuries were increasing during the study period at a rate of about 2.4 injuries per 100 employees per year. And we saw a similar trend in the post-intervention period. More importantly, though, by looking at that level change variable that we can see on the screen, we were actually able to show then that injuries did decrease after the intervention period. And this plot also tells us why we probably didn't see these changes in those simple pre and post tests, because that increasing rate in the post-intervention period completely washed out that change. And then finally, we were able to compare this against a counterfactual line, which allowed us to estimate that in the first year following the power stretcher intervention, we saw a substantial reduction in injury rates to the effect of about 48%. To confirm these results, we repeated this whole set of analysis, but this time by including a control data series. And in this case, we chose occupational exposures. So these are injuries that occur to everything else, things like chemical and infectious agent exposures and things like that. And so these are shown in pink along with their fitted lines. And the important finding here is that we found nearly identical estimates for the level change, trend change, as well as the post-intervention changes. But in this case, it's actually relative to a counterfactual that now includes some control group or comparison. And then finally, this last graph here shows us the average injury rates for each month across the entire 11 years of the study period. And when we look at this, we can kind of get a sense of some sort of systematic or fluctuating change across months. And we were able to confirm this by fitting a couple different regression models to the data, which had significant monthly terms and explained about 18% of the variance in injury rates across the year. As you can see from the graph, they also showed us that injury rates were highest in December and January, but tended to be lower in the spring and fall months. And then just to wrap up, not shown are logistic regression models, which interestingly enough revealed a small decrease in the risk of patient handling injuries as employees got older. So almost the exact opposite of what we would expect, but no difference between males and females. So to wrap things up, these results certainly add to the evidence that power assist stretchers can be helpful to prevent injuries in EMS providers. But in this cohort, the effects were a lot less apparent when we were making simple pre and post tests, and also when we were expressing injuries as a function of workforce or the number of employees. We also showed that injury risk was high in both ambulance and fire providers in this urban dual response service, but more importantly, that this also fluctuated or varied both over time within each year, as well as across employees, being greater amongst those ambulance paramedics as well as younger practitioners. So the findings suggest, I think, a few things. First off, that services should probably take these things into account when they're designing their injury prevention programs. Much too often, I think, in ergonomics and other areas, we kind of provide these one-size-fits-all interventions that are done at convenient times. But this data, I think, indicates that we should be a lot more sort of nuanced than that, you know, different employees are going to have different concerns at different times of the year. Something that's really interesting to us is to try and understand why the injury risk was so much higher amongst our ambulance paramedics compared to the fire providers, even though they both were responding to medical calls. And our suspicions are that this has something to do with an increasing number of medical call volumes, perhaps maybe some organizational factors that we have yet to uncover, and a few other factors. And then lastly, I think the findings steer us in the direction of a couple interesting or promising areas for future studies. So thank you so much for your time and attention during this. I'm happy to answer any questions if they pop up.
Fantastic presentation, Rob. I really appreciate that. Any questions for Dr. Price? And again, as always, feel free to plop them in the chat if you'd like to type them, or if you feel comfortable and you want to unmute your mic, you can feel free to ask them as well.
I'll start with a quick one. Maybe I missed it, but do you have any idea why you see this seasonal effect?
Yeah, I think we can guess, but I'd really like to test it. You know, when I look at the seasonal effects, the first thing I think we thought was maybe it's because of differences in the number of call volumes. So there's certainly busier and quieter times of the year, but we see almost the same seasonal effects when we calculate the injury rates as a function of call volume. So that gets washed out. The other one that comes to mind, of course, is, you know, temperature and environment and things like that. But I think we'd like to do some more formal analysis, you know, to confirm that, to look at things like precipitation or temperature, or a few other factors, because it, you know, it could be possible that maybe people change how they respond to calls or how they practice as a function of other things that are happening, or maybe there's organizational factors that come up at different times of the year. So I don't know, hope that answers the question, but maybe doesn't at the same time.
It does. Thank you. It was a great presentation.
I think we've got a question from Dr. Bergeron.
Hi, Rob. Thanks very much for the presentation. Just wondering if you were able to collect data on injury body, the location of injury, whether it's back injuries, knee injuries, shoulder injuries, and maybe seeing if they were reducing in one area, maybe increasing in another, or
Yeah, we have that data. I haven't had a chance to roll up our sleeves and look at it. I mean, being a back guy, that's always where I go first. We do know that most of these injuries that happen affect the back, about a third of them, and then the rest are all over the map. But I can't tell you whether or not these things preferentially, spare the back at the expense of, shoulders or things like that. We have some anecdotal evidence maybe that using these stretchers is a bit different, but we haven't tested that yet.
Okay, thanks.
Awesome. Any other questions? I've got one last one, maybe we have time for. One thing I was going to ask, kind of along the same lines as Glenn's question, is there a reduction? There's a reduction in the number of injuries, which is great. Is there also a reduction in the kind of average amount of time somebody's out of work because of that injury? Because maybe it's affecting these small injuries that people recover from quite quickly, and then doesn't really impact these large injuries that have people out for a long period of time, or maybe it's the opposite. So I wonder if not only the nature of the injury, but the impact on the workforce, how these power-assisted stretchers influence them.
Yeah, super good question. I know a couple existing studies have shown that the average amount of lost time, or the average duration of lost time, went down, and we have some of that data available to us. We're still in the process of kind of cleaning it, but that would be, the slam dunk, that not only do we reduce the number of injuries, but we also make the lost time ones less severe, because that's a huge driver to costs and obviously quality of life and everything like that, for sure.
Of course. And as a follow-up, is there such a thing as a power-assisted stretcher-induced injury, like a specific power stretcher injury that is caused by it?
Yeah, well, I'll take the time to acknowledge for sure one of my co-investigators who's here nicely in the audience, Neil McDonald, but we've actually chatted a little bit about that. There's definitely differences in how these power assist stretchers are used, and Neil would be much more familiar than I, but they're heavier, they're harder to maneuver, and some people hurt themselves by like pinching a finger between the stretcher and a doorway or things like that. So we've thought about it for sure, but I don't know if we've got the data to measure it.
Gotcha. Very interesting. All right. Well, if there aren't any more questions, I think we'll move on to the next presenter. And again, if you've got more questions for Rob, feel free to plop them in the chat. So our next presenter is Dr. Harry Liu, who's in fact the newest member of the Department of Kinesiology and Applied Health, and we're really excited to be able to hear about his research and what he's going to be able to bring to the department in terms of new expertise in the area of kinesiology. So please, Dr. Liu, the floor is yours.
Okay, thanks. Can you guys see the PowerPoint? Okay, great. Give me one moment. Yeah, nice to see you all virtually from this Zoom meeting. So the topic I will be presenting today will be investigation of skills, technical knowledge, and game performance transfer in badminton. So this study built upon from a pickleball perspective, try to examine the transfer effect between pickleball badminton. Let's move into the background. So the dominance of multi-activity model in PE raised a debate to the sequence of teaching and learning similar sports, such as invasion sport or netball sport or striking fielding sport. So the logic in here, people are thinking when you're teaching similar sport, so because the sport shared similar movements or strategies, so that's why the sequence of teaching one sport to another is really important for PE teacher or for motor learning. For example, if you're thinking volleyball, tennis, or table tennis, so they are shared similar offense-defense skills, and also share even similar score systems. So they are trying to striking object, which means the ball, to overnet score in open space. So that's a logic in here from the debate. So back to the definition of transfer of learning. So the sequencing of skill and the concept to be learned in two or maybe more than two sports. So that's a definition for transfer of learning. So there are three possible results from transfer of learning: positive, negative, or natural. So we have the expert in here, Dr. Richard. You are a sports psychologist and you know motor learning, motor control than me at least. So that's a possible result from the transfer of learning in motor learning perspective. And also there are other disciplines, for example, from reading, learning, writing, and from geography. So there are a lot of research already have the positive result from transfer of learning, which means when you learn writing, reading, and English literacy, so there are transfer effect between those skills in literacy education. And back to our area, sports science or PE, physical education, previous literature already reported positive transfer of learning in, for example, in shooting skills in basketball. So they found the shooting skill in basketball can be transferred to dart throw. And there's one study also published in 2017. Researchers examined soccer, skilled learning transfer from similar sport, which means basketball, or dissimilar sport from tennis to tennis. And both of those parts came from motor learning skill acquisition. And in PE area, in sport pedagogy area, there's one study published in 1999. Mitchell found there's a technical knowledge transfer from badminton to pickleball. The study in here in 1999, the sample size is really small. They only used handful participants in their study, and the measurement is not validated, but they providing some implication. There's a positive transfer from technical knowledge in badminton pickleball. And back to our research. So as I mentioned, a lot of study, tons of study published in skill acquisition in motor learning areas. So a typical motor learning skill acquisition study will be compare blocked practice, randomized practice, or even like, for example, self-adaptive practice. Try to compare which way is better to helping whether students or participants to improve their learning, motor learning, or skill acquisition. But in sports science, in motor learning, you have one domain. So motor learning skill acquisition belongs to psychomotor domain. But in PE, we have at least three. So we have a psychomotor domain, we have a cognitive domain, which means technical understanding or technical knowledge and your game competence, a mixture of your skill combined with your technical knowledge. It's your game competency, right? It's your game performance. Then in PE, we also have social skill domain. So based on the previous study, we are thinking the positive study in skill acquisition may apply to cognitive domain, which means technical or game performance from one sport to another. So that's the guess. That's the hypothesis we are thinking. It brings to our research questions. Our first question is there a transfer of learning effect between pickleball and badminton? Because they are similar structure, similar score system. They play in a similar court. Then the second one is, according to the positive transfer effect in skill learning, is there a positive transfer effects in cognitive domain, which means technical understanding and game performance. Moving to our methods, so we have 34 participants in this study, came from land-grant university in southeastern of the United States. And so it came from 2 intake classes. The class schedule will be meeting Monday, Wednesday, Friday, 3 times per week. And each lesson lasts 15 minutes. We have a total of 15 weeks in this study. And in this design, we have 2 classes. So class 1 will be group 1. They are learning pickleball first, then badminton later. And then group 2, which means class 2, they are using reversed sequence in learning badminton pickleball. And in this design, we use the 2x2 repeated measure ANOVA to analyze our data. And we have 4 variables in here. The first one, we have 2 skills. One is wall volley, and the second one is French clear. And then we have a technical knowledge. We used technical understanding to measure students' technical knowledge in badminton. And there are 2 components in this study. So the first one is selected stroke options, and the second one is selected arguments options. So I'll explain more details about the test later in here. And then we also have game performance. So we used GPAI game performance assessment instrument to assess their game competency. So there are also 2 subcomponents in GPAI, decision-making index and skill execution index. Okay. So before I move into the detail of the measurements, so let's give you a brief review of the framework of the lesson plan. So we have pre-test before we start in the semester. Then we have week 1 to week 5 to learn whether pickleball or badminton first. Then after the first 5 weeks, then we move into the second 5 week. Students switch to learn badminton or pickleball. It depends which sport you learn first in your first 5 weeks. And after week 10, we have a 5 weeks game season, student playing badminton and pickleball games in here. And then we have post-test. I will explain a little bit more later why we didn't do the immediate post-test after week 10, after my conclusion. Okay. So let's jump into the detail of the 4 measurements. So wall volley, so students are required to stay in front of this line to play shuttlecock against with the wall, and so within 30 seconds. So in here, all the shuttlecock need to play above this line. Then we are just counting how many they can finish. They can accumulate within 30 seconds. Then the second skill test is French clear. So we have one server staying in front of T, serving the shuttlecock to here. Then participants, at the beginning staying middle of the court, half court. Then based on the serve, moving to here, then play the shuttlecock back to here. So this is based on the playback landing a specific area. So we can calculating how much point they earn from each playback. So this is 2 points area, this is 4 points area, and this is 5 points area, this is 3 points area. So they have 10 serve, 10 playback, so which means the maximum score for each playback will be 5. And then the maximum scores will be 50 points based on the 10 French clear tests. For technical knowledge, there's a student required to watching a video clip, which include 19 scenarios for actual badminton play. So in here, that's one of the scenarios in here. So 2 person play back and forth, then the window will be freezed, then switch to animated badminton court in here. Then we just told the students, so X is representing this person, is you, and then the blue dot representing your opponents in here in this video. So based on the freezing of the screen, you have 3 options in here to play your stroke back. So option 1, 2, 3. So you need to choose the best option you are thinking is to play back to your opponents. Then your students also need to choose 2 arguments to supporting their SSO selected stroke options. Then also have game performance. Each student will be recorded pre and after the intervention for twice. For each video will be last for we're recording for 7 minutes. So we're only coding 5 minutes for each gameplay. And so this is one of the video we have recorded in our post tests. So this happens in the game season for the gameplay, for the badminton gameplay. And then we also have pickleball games in the game season. This is a pickleball game we have played in the game season. So the net is almost same, except the net height was changed, and the court is also same. And they're just using pickleball paddle and to play pickleball here. And moving to the result. So based on our design, based on our pre and post measures, and based on our 2 groups, pickleball first, badminton later, and badminton first, pickleball later. So we found a significant time effects across all variables. So wall volley, French clear, those 2 skill tests, and technical knowledge in here, and game performance. So which means all participants improved their skill, technical knowledge, and game performance after 15 weeks intervention. But we didn't find any group difference between group 1 and group 2. And go to the conclusion. So we believe both groups improved their badminton skills, technical understanding, and game competency after 15 weeks of intervention. And we are thinking learning pickleball before or after badminton did not appear to have a transfer effect, whether in skills, technical knowledge, or game performance in our study. But of course, there's the limitations. So we only have 2 classes in this study. It only came from 1 university, so which means our internal validity need to be improved, or any future study need to focus on try to recruiting participants from diverse backgrounds, whether from different skill level or different ages, to try to increasing external validity, internal validity, and to try to validate our study. And the second limitation here is we're planning to do our immediate post test after week 10. The reason we change our plan because the COVID is still ongoing right now. We have students in quarantine within the semester from week 2, week 3 until week 9. So that's why. So it's not like small number, not only 1 or 2 students. So that's why when we're asking students, should we continue to, planning our post-test after week 10, then they are thinking, no, we're not ready. I just out of quarantine. I still need time to practice my skills, practice my game competency to play some games. So that's why we have to start the game season after week 10 to allow them to, to get more time to practice, to play. So that's why we are thinking the extended game season may moderate the transfer effect between, group 1 and group 2. And there's third limitation. We didn't measure any skills with pickleball and any technical knowledge with pickleball and game competency in pickleball. So we are thinking, so probably there's a reverse effect, like learning badminton, then later to pickleball. So may have some effect in pickleball skill learning and the technical understanding and game competency, but we don't know. We didn't measure this part. We are focused on badminton. So maybe this is another weakness we need to collect in the future. So that's a study from this spring. Yes, thank you. Any questions?
Thanks so much, Dr. Liu. Thank you so much, Dr. Liu. I'm now opening up to any questions from the audience. I see Rob is raising his finger there, so.
Yeah. One of these days I'll figure out how to ask questions on Zoom. Anyway, thanks, Harry, for a great presentation. It was really interesting. I was thinking about, I think you had a comment in your limitations that you thought that maybe the extended playing season moderated the effects. So I guess I wonder, did you go into the study expecting to see transfer? And if you did, might there be other populations or circumstances where that transfer would be more evident? And I guess every time someone says pickleball, I think of older adults. So I'll maybe end my question there, but I'd be curious what you had to say about where you might see that effect as opposed to not.
Yes, when we're planning our study based on the literature we found, so we know a lot of skill transition from soccer to other sport, from soccer to field hockey. And there's one study I mentioned in the PowerPoint. So Mitchell published one study from technical knowledge transfer from badminton to pickleball. Mitchell used the same test we used in here for the technical understanding, but he only measured about this part, and the result was positive. So that's why we are thinking, and back to the P area. So right now, the dominant model in across the world is multi-activity model. So which means students need to learn diverse sport within one semester. So you may learn 2 or 3 sports within one semester. So that's why the P teacher always arguing which sport I should teach in first. So should I teach in soccer first or should I teach in basketball first? Then back to our field, we are thinking pickleball, volleyball, and badminton, tennis, they are really similar. That's why we are thinking, okay, probably there's a potential transfer from one to another if you're teaching, different sport in different sequence. And a lot of people, older people, adults, to play pickleball. We are thinking about probably all of the participants came from university. They are college students, and they are more active, right? And that's why I'm thinking for the internal validity and external validity. So when you're thinking about middle school students or teenagers or kids, so probably the result will go to different directions or give different results. We are still planning, we are still thinking about the study, so we can reorganize in the future. So I hope if we have badminton court over there in Winnipeg, so I'm planning to reorganize the study in whether summer or next fall.
Yeah, great. Awesome. Thanks for that. Yeah, it sounds like a whole bunch of really fascinating follow-up studies or potentials.
Thanks.
Thanks for that. Does anyone else have any questions? Oh, yes, Glenn. Oh,
sorry.
Sorry,
I hit the mute button twice. Thanks very much, Harry. That was very good. I'm just wondering if the going back to some of the things that Rob would say, and like pickleball is being picked up by the older generation quite a bit, but and largely it might be because of the complexity of the difference in the complexity of the two games. That badminton is, I think, is more complex than pickleball in terms of, you know, there's a different types of racket, the speed of the birdie, and the movement that has to happen on the court is probably much more different, much more complex, I think, in badminton than it would be in pickleball. I'm just wondering if maybe that has something to do with transference of information if you're going from badminton to pickleball, which is complex versus simple.
Yeah, I appreciate your opinion and suggestions. Yeah, I talked with my major advisor at Auburn. We are thinking, so when we try to design this study, I was thinking, why we're not using pickleball or tennis, or maybe table tennis to tennis, or tennis to or table tennis to pickleball. It will be more similar, right? So then but you know, because everything was messed up right now due to COVID, so we are thinking, okay, we only have 2 classes organized in this spring, the past spring. So there are 2 badminton classes. So then, you know, convenience sample. So that's a available resource we have in the spring. So let's try, and the one literature published by Mitchell is based on badminton pickleball. So we are thinking, why not just try to replicate his study to see what happens. Since Mitchell only has 9 participants in his study since it's 1999. So we are thinking, why we not just try to replicate his study and extending to kind of more skill tests and then game competency, then we can see what happens, right? So can we replicate the result? So that's the reason we're starting this study. And yeah, we are thinking about like tennis pickleball or pickleball table tennis. They are more similar, you know, striking and racket sport, and even similar, pressure when you try to finish your skills. But it's still ongoing. So I was thinking, I talked with, like, as I mentioned with Rob. So if we have court over there, we have class over there. So we're planning to try to, push this project moving forward so we can checking those record sport transfer effect. Back and forth. Yeah, thank you. Thanks.
When you get here to Canada, you'll be introduced to hockey, and I've always had this opinion that that ringette is a great precursor to playing hockey. So you might want to even think about looking at the transference from ringette to hockey. When the ringette, they have it's just a stick and a ring that they use, and the hockey, they've got a hockey stick and they got to manipulate a puck in a very different way. It'd be really interesting to see what the transference is from going there and back. That would be a really interesting study.
Yeah. Okay, yeah, looking forward to about that. Yeah, thanks, thank you.
Thanks, everyone. I think unfortunately Yannick had to, well, not unfortunately, but Yannick had to go and teach, and so it's left to me to introduce myself as the next presenter, and but that's all right. I think we're gonna, let me just share a screen here. Is everyone able to see this all right? All right, so thanks everyone for joining. I'm actually going to be speaking about an ongoing study. So this is a study that I'm currently, that is still active, and I'm still embedded in. And it's entitled The Workplace Experiences of Firefighters and Paramedics in Winnipeg During COVID-19. And this is a partnership development grant between myself and collaborators at the Winnipeg Fire Paramedic Service. And I just want to maybe share a bit of background and rationale associated why I've chosen to sort of orient towards studying these remarkable practitioners. It's safe to say that we have, all of us, experienced mass disruptions in our lives as a result of COVID-19. And as Dr. Price was alluding to, he had touched on that particular subsection of first responders, firefighters and paramedics. Their everyday work experiences routinely involve physical, psychological and emotional stressors. And Dr. Price sort of went into the physical stressors, and I'm sort of looking at a different domain. It's a good way of maybe describing it as a nuts workplace. And this is an acronym that has emanated out of the Center for Studies in Stress and Human Health out of University of Montreal. And that acronym stands for novelty, unpredictability, threat to ego, and loss of sense of control. And that's the S. And that is sort of the encapsulation of the work of paramedics and firefighters. Now, unfortunately, the cumulative effects of those stressors, if not processed properly, are fairly well documented in the literature. We know that if sustained stressors exist and persist, there's decreased health, decreased emotional well-being, decreased morale, perhaps organizationally or more broadly, increased cynicism, and certainly the potential for burnout. And so given this unprecedented disruption to work and life, it's essential that we learn from first responders, from paramedics and firefighters to better prepare the organization for future emergencies or future mass disruptions. And it's also important, given that first responders and specifically paramedics and firefighters are not a traditionally focused on group. There's actually a paucity, a lack of research that specifically features the voices of firefighters and paramedics, or those on the front line. So I just want to acknowledge some contextual considerations. As Dr. Price alluded to, the WFPS is a combined service. So there's an EMS side, so the paramedicine side, and the firefighter side. And typically on a medical call, it could be that a firefighting crew with one firefighter paramedic, a dual trained practitioner, attends a medical call. It's also possible that on a medical call, an EMS crew, a paramedic crew is called, and generally they have dual qualified in what's known as a PCP, a primary care paramedic. It could be two primary care paramedics, or it could be an advanced care paramedic and a primary care paramedic. So it's typical in Winnipeg's context that it could be that both are dispatched to a call, and that a PCP crew then might transport patients back to the hospital. Now, the study objectives associated with this study is, the purpose ultimately is to describe WF personnel's workplace experiences during COVID-19. And so the first sort of study objective is, how are firefighters and paramedics responding and managing the COVID-19 pandemic? Number two is to get descriptive descriptions of WFPS employees' feelings of safety and support while on the job. And then number three is, how are those strategies and lessons learned being incorporated into everyday practice? And so I have sort of a dual methodological, a mixed methods methodological approach, which is actually in a sequential design. And so it started with surveys, and once those surveys were completed, it moved into interviews. And so I just want to touch on a bit more detail associated with each one, and also acknowledge that timelines are actually quite important here. Beginning in May 2021, my partner at the WFPS communicated to the organization about a memo informing their employees of the study to help with recruitment. And once that memo was sent out, a link was set up via Qualtrics to conduct an online survey. The end of September 2021 is when that survey has closed, and the interviews started to get scheduled in August of 2021, so the middle of summer, and those interviews are still ongoing. So I just want to just share maybe the current state of the study and surveys. So we had 139 surveys completed, and these surveys were all self-reported measures, which made up of 4 different surveys. One was called the Coronavirus Anxiety Scale, which was on a Likert scale from 0 to 4, which attempted to assess levels of anxiety related to coronavirus. The obsession with coronavirus scale was also on a Likert scale, and was encapsulated with a question such as, I have disturbing thoughts that I may have caught COVID-19. And so that was just one of the examples. And it was on a Likert scale from 0 to not at all, I don't think about that whatsoever, to I think about that every day. The third survey was known as the Hero Daily Experiences Index. And the purpose of this survey was to develop a score, a set indicator that provided a snapshot of healthcare workers' daily experiences. And the focus specifically is on sleep, everyday pain or workplace pain, fatigue, and emotional distress, encapsulated with an example of this particular survey item was, last night I had trouble sleeping. The last survey item was focused on PPE, hero protective equipment. And the goal is to estimate the number of healthcare workers who are having problems accessing appropriate equipment. And this particular survey item was modified to just change the equipment to make it WFPS specific. So some of the names of the equipment were a bit different, but we modified it such that it was organizationally specific to the WFPS. And again, a example of this potential question was, during the last day of work, did I have a problem accessing appropriate equipment such as a respiratory mask? And again, this was on a Likert scale from 0. I had no problem accessing equipment, all the way to, this was not applicable to me. I work in an office setting, essentially. Now, just in terms of where we're at, so like I mentioned, this survey closed at the end of September. The statistical analysis is ongoing, but in general, I can share that there seem to be low indicators of anxiety associated with the coronavirus anxiety scale. And again, same with low indicators of obsession with coronavirus. But again, I think this is worth looking into as we start digging into the data in a bit more detail about looking at some of the variables that we need to dig into the data associated with. So after people completed surveys, there was an opportunity to indicate whether they wanted to participate in follow-up interviews. And so as people started filling out the surveys and indicated that they were open to participating in an interview, my research assistants and I reached out and attempted to schedule interviews. So currently we have 24 interviews that have been completed, with the 7 additional interviews that have indicated that they're open to being interviewed, but we're still scheduling and actually conducting those interviews. Now, what I can share thus far, so the reasons why we want to do interviews is to actually essentially supplement the findings from the surveys and ultimately draw out rich narrative descriptions of the participants' experiences on the job during COVID-19. Now, of the interviews that we have completed thus far, All were digitally recorded and transcribed verbatim. And again, preliminary sort of findings is approximately, these interviews lasted approximately 46 minutes, with the longest being approximately 2 hours to as short as 30 minutes. And again, more to come. And I can share specifically about this is that the analysis of the interviewed has begun. And we're utilizing Braun and Clark's reflexive thematic analysis. So this is a 6-step process where we really familiarize ourselves. Essentially, the first 2 steps of this process, of these 6-step process of reflexive thematic analysis, is to really familiarize yourself with the data. How do you familiarize yourself with the data? Is you read the transcripts and you familiarize yourself with this data, and you make notes. And my research team and I are embedded in this process at the moment. And again, just because we are in this process, we're still coming up with some of the codes and themes associated with the data. But it's fair to say that, I think just, more from the survey data, there's an opportunity for people to just share some final thoughts and takeaways, or any suggestions for change as part of the interview process. And so within the surveys, our participants responded by sharing that some of the descriptive responses have included that they really appreciate ongoing, continuing professional development, and in particular, given COVID, that they are looking for increased training opportunities on donning and doffing of protective equipment, particularly as they go to suspected patients who might or might not have COVID, but also increased understandings of protocols and procedures associated with that. Another sort of finding that I can just share that a lot of participants have brought up is that workplace communication, certainly there's some potential for improvement, particularly in terms of online accessibility. And I think a lot of that has to do with the potential that, especially if you recall, in the summer, in the lead up to summer, in the spring, there was we were going into finishing the second wave, but then there was rumblings about a third wave. And as a result of that, there was a lot of changes associated with protocols and procedures. And sometimes those protocols were changing upwards to 1 to 2 times a day, not just a week, but a day. And as evidence and experiences were being developed by different individuals and supervisors, that these had to be communicated broadly towards the organization. And then lastly, I think a lot of individuals were acknowledging that there were some different mental health supports associated with the organization, and these were very much valued, and that they were very pleased to see that these were being implemented and certainly encouraged and destigmatized. So again, this is an ongoing project. I am still in it. And so next steps really is completing data collection. So really just finishing off the last set of interviews and completing both the statistical and qualitative analysis and thematic analysis associated with the data. And associated with these next steps is IKT, both non-traditional integrated knowledge translation strategy and both traditional integrated knowledge translation strategies. And this is actually being conducted, again, with my colleagues at the Winnipeg Fire Paramedic Service, as well as colleagues at the Center for Healthcare Innovation. And so this is continuing, and I'm pretty excited to continue this process to ultimately make sure that we extrapolate those lessons learned and share them not only with the leadership of the Fire Paramedic Service, but also ultimately and perhaps most importantly, with the frontline practitioners um, who serve the citizens of Winnipeg currently. So again, there is some special people to share and to acknowledge. And first off, given just how busy a lot of these fire paramedic personnel are currently, I really want to thank the participants, and then certainly the WFPS team, in particular, Mr. Neil McDonald, who has been just a really solid counterpart and collaborator. And then certainly my research assistants, Miss Rebecca Hume and Miss Sarah Tellis-Langton. So with that, I'm going to stop sharing the screen and open it up to any questions that that there might be associated with this.
Yeah, I will jump in since like we like when we're conducting educational research, so we have a lot of interviews, and I just really curious. I know you mentioned about your survey was related to anxiety about COVID, right? So when you do your interview, so do you have a specific theory, or you just use the same theory, consist of your survey to implementing your interview? So I just a little bit curious about the framework of your interview.
Yeah, so I really appreciate the question. Ultimately, the theoretical framework that is informing this study is workplace learning. So the learning as it occurs in a professional workplace. And I remember describing that NUTS workplace: novelty, unpredictability, threat to ego, and loss of sense of control. And that framework ultimately informed the interview guide. And the whole purpose of the interview guide was to leverage the findings of the surveys to draw out rich narrative descriptions of the challenges and barriers faced of working in the midst of COVID.
Yeah, got it. Thanks. Thank you.
Yeah, thanks for that. Doesn't look like there's any other questions. So I guess I'm also going to kind of, as I'm emceeing here, I'm going to maybe change my metaphorical hat here, and just I want to really extend my deep appreciation to all of our presenters and all of you guys who are joining us, especially students. This is our 8th annual KINect Research Week, and they're only getting better. The breadth and depth of research being conducted within our department is only becoming more wonderful and more just featured, and really it's really wonderful to see our department members and just increasing our level of output, our level of productivity, and the breadth of the research being conducted is pretty fantastic. And so again, I want to thank all of our presenters, all of our students who are joining us, and to really reiterate, especially the students who have taken time out of their day to join us and to getting to know our profs, and not just from teaching, but actually getting a bit more of our other professional responsibilities that we have here at the University of Winnipeg. And so for students in the audience, or if you were watching this in a Zoom recording, reach out to your profs and interact with them and ask them questions about this. And you'll find that we're really excited to probably chat with you guys about our passions. And so everyone, thank you very much for joining us in the KINect Research Week. As chair of the Departmental Research and Ethics Committee, I want to thank my colleagues, Natalie Riche and Yannick Molgat-Sion, for all of their assistance, all of their help. And again, thank you everyone for joining. And I hope everyone has a fantastic weekend and have a great day, everyone. Ciao for now.